Okay, welcome back to our video series for 200-ton oceans problems, the sample exam. And in this video, we're going to talk about question number 6. Question 6 reads, the great circle distance from a latitude and a longitude to another latitude and longitude is 4,559 miles on a course of 121 for the initial course. What is the longitude of the vertex? Looking at the answers provided, we can see that they're actually pretty far apart. And so when we're thinking about how accurate we need to be, as long as we get it to the nearest degree or two, we're going to be just fine. Complicating factor for some people is that this is in the southern and eastern hemisphere, not where most Americans live, but we live on a globe, so that's no problem. So the first thing I did was set up the information that we know, our position, where we're starting, where we're going, the distance in the initial course, and we're looking for the longitude of the vertex. For these kind of problems, I like to draw out a little bit of the situation and see kind of what is happening. So in this case, if this is Greenwich, we're in the southern and eastern hemisphere, and we're starting out, at a position 35 degrees south and 19 degrees east, so just a little bit east of Greenwich. And then we're heading to a position that's less south and further east. So this is maybe a little exaggerated, but the great circle that we take is going to be like that. And what we are looking for in this problem is the position of the vertex, only the longitude in fact, but we'll calculate both. If we go from position A to position B along a great circle route, the vertex is going to be the point that is closest to the elevated pole. In this case, the most distance poleward to the south is the vertex. And this information is useful if you're planning a voyage. You don't want to get into too high of a latitude oftentimes. So that's why we do these kind of problems. The other thing that I would do is convert all of these into decimal degrees so that I can punch them into formulas later. So I'll do that. So once I have this information, it's really just a question of plugging into formulas. So these formulas can be found in Bowditch in the sailings chapter. So once we have all of our preliminary information, it's really just a question of plugging into formulas. And so the first thing we need to do is get the latitude of the vertex for this position. And that formula is just this here. Again, you can get this out of Bowditch Volume 2. So I'll just go ahead and solve that one. This is latitude 1 and the sine of the course angle that we're using there. Okay, so we found the latitude of the vertex. It wasn't asked for in the problem, but it kind of makes common sense to do that. And you also need this for determining the longitude. So in order to get the longitude, we're going to get the difference in longitude of the vertex, and here's the formula from Bowditch. Right, and so the latitude of the vertex just goes in there, and then the course angle just goes in for C. Okay, and now you may have noticed that I put in the value of 121 for this C. As you saw in a previous video, you can follow the strict naming schemes for course angle, or if you just type it in and mentally draw the picture of where your course begins and ends, you'll realize what the course should be. So I find that easier than messing with the course angle stuff. Okay, so the difference in longitude of the vertex is 46.22 degrees away from where we started. And so if our original longitude was 19.433 east, and we changed it by 46.220 degrees further to the east, then we will add these up and get our longitude of the vertex. And the Coast Guard is looking for this not in decimal format, so we'll have to just change this. All right, so we calculated the latitude and the longitude of the vertex. Looking at the question, given the choices here, ours is closest to choice C, which is the correct. We're off by about 6 5 or 6 nautical miles, which is fine on this type of problem. Again, look at the spread of the answers, and we're good to go.